Jansen is saying that I'm not letting it go at full speed. Let's go. At some point in history, this object here was all the rage with kids when I was about 7 or 8 years old and lived in a little wooden house in the countryside of Sao Paulo. In P8, my father bought a lathe. It's a tool we have here at Manuel do Mundo, which we used to make perfect balls. It has a motor on one side. Then you clamp the wood in the middle and spin the wood. With a chisel, you start shaping it all day. You start wearing down the wood. My father made, no joke, about 40 different spinning tops on the lathe. All the shapes you can imagine. He was really good at this thing. How does it work? You wrap a string around here, start winding the spinning top with the string like this, or rather, you start winding the string around the spinning top, and then you throw this thing. I don't know if it starts spinning in the air or if when it hits the ground, you pull, and that makes the top spin. That's what gives it rotation. Throwing it with the string wrapped around. I never managed to do it. My brothers never managed to do it. But when a friend of my dad came over to our house, then things changed. Not only did they play with the spinning top really well, but the challenge was to throw your top, try to hit the other person's top, and knock it out of a circle that was drawn on the ground. Yeah, I know what came to your mind. Exactly. About 15 years later, they made this game all fancy and called it Beyblade. Let's be honest, it got a lot easier. You pull the thing, there's even a special arena. Sparks fly. And it breaks apart in all sorts of different ways. The risk of hitting your friend's shin is much lower. Was it just me who kept getting hit? Or is this thing really hard to play? Let's see what the new generation thinks. No pressure. You're the only one here who knows how to play. Actually, I haven't played in years and might not remember how. And he's really good. He dodged it easily. Let's see. Nice. Almost. Nice. Yeah. Thanks, Paulino. Yay. Ah. No, what is this? He called him the pro. He's a professional, right, guys? He is. Whoa. That's cool. But the fact is that on Instagram the other day, I saw a short video of a guy in the United States who also bought a lathe and decided to make a spinning top, but he decided to make spinning tops of a different size. They were spinning tops about 50 centimeters in diameter, and then he made the spinning top spin with a drill. It would spin for a long time. It was a beautiful, beautiful thing. I fell in love with this project. I already went to check our lathe's measurements, and our lathe is ridiculously small to do a project like this. But we recently hired an engineering intern who's really good at 3D printing, so what was my idea? We can make the top's shaft with a threaded rod, a steel rod that has threads, and around it, we fit several 3D printed parts. We can't print it all at once, since our printer isn't big enough, but we could split it into pieces and screw them together. Would that work? I was thinking it would be 70 centimeters in total. So here we'll have a steel tip. From here, we start the 3D printed shell up to here. I think it can be a single piece, but there will already be plaster. Yes, so let's think that there's a shaft here, and then we could have several 3D printed layers. So looking from above, I imagine something like this. That's how it's going to be. Then there's a hole. Then we divide this into 4. Let's move this piece here. It'll be this one and that one. This is the piece we'll print. Perfect. How will it fit with the others? I thought about putting a screw here, a screw here, a screw here, and a screw here. I think these screws need to be as close as possible to the center and as close as possible to the end. Since those are the most critical spots here, it doesn't really matter. We'll also need to screw this into the bottom layer. So we need, let's say, 2 screws per piece here to secure it. You have to figure out where this piece would hit the floor if it falls. In this case, it would be here. So this wall would need to be reinforced. I'd reinforce the piece to keep it simple and avoid complications. Still, adding some glue here seems smart, right? As we put the modules in place, we'll fill them with glue to lock everything in completely. We could even put glue between these pieces here. Yeah, I think that will also help prevent the plaster from leaking when we put it in. Yes, one will be well supported by the other. There will be a lot of contact. Good, good. Mission assigned.
Mission accepted.
Let's go. There.
Let's see how the giant spinning top print is going. We finished printing one of the pieces here. Look how it turned out. Look how huge it is. All this structure here is support. We're still going to remove it and the piece will be completely hollow on the inside. So there are 4 pieces like this, and we use these holes to fit one piece into the other with screws. And that's also we made this ridge here, so it can make contact with the other pieces. Here we have some other examples. This piece still had a problem. We'll have to redo it. Just some of the fittings. Here's an example of the fittings we'll use. The spinning top will be huge. See how interesting this piece is. There's an opening for the threaded rod to go through. We'll have 4 pieces like this, and the rod will be placed in the middle. And here, we're still deciding what we're going to fill it with. So, here's an example of a piece that went wrong. It was printing, and with 40 minutes left, there was a problem with the printer. So I'm still going to try to save it. I'll print the missing part here and glue it. And I'll try to figure out what went wrong with the printer. But we probably won't lose this piece. We're still going to use this piece in the spinning top. Each piece takes about 19 or 20 hours on average. So it's taking a long time, almost 1 piece per day. To assemble this piece, we use some strategies. This part here will be the area that touches the ground if the spinning top falls over. So we made a much thicker layer here. You can tell by the sound. It sounds very different from this less reinforced area. This makes the spinning top much more resistant. We're using 8 walls, about 3.2 millimeters thick. That's a really solid wall.
Lesson is dealing with the 3D printing. I'm going to prepare the spinning top shaft. This is it. It's going to be this threaded rod, this piece of steel with threads around it. I got a threaded rod here that's 20 millimeters in diameter. It's pretty heavy. This must weigh about 3 or 4 kilos. So what's the idea on the end? We're going to put 2 nuts, and I'm going to use the welding machine to put a bit of weld here on the tip. Then I'll try to round it off. So we'll have an end here with nuts. Then we build the whole 3D print around it. It has to be something really tight, really precise. The cool thing about this rod is that it guarantees that precision. It's really straight. And on top, with 2 more nuts, we tighten it to put everything together, to tighten everything. And at the same time, we can already use these nuts to be able to spin it with the drill, because we won't be able to spin this with just a string. I'm going to try to do here is lay a lot of weld on the tip, then grind it down to form a half sphere. That's not very simple. 3 different things: the nuts, the bar itself, and this bunch of weld blob that I'm putting on top. But it's a way for us to create mass. So later, I can try to make this hemisphere here at the tip. The idea here is not to have a needle at the tip of the top, because if it's too sharp, it'll dig into the floor. It's very heavy with the rounded tip. We'll be able to minimize its contact with the floor as much as possible without making it pointy. It doesn't look good, does it? But I think it'll work. It's not great. It's wobbling on the floor. I need to improve this. Look at this. That's beautiful. Let's assemble the spinning top. Look at the size of the mess Alyson made here. How many pieces are there?
There are 10 pieces in total.
Okay, is it really 10?
Yeah, if you count these little tubes, it's 12.
Look at the support here. Is it called a tree support?
Tree support. Yeah.
The support is a kind of scaffold in 3D printing that we use to print these parts that are very horizontal and don't have anything underneath. You need to put something, a support, underneath. Since the piece is huge, it needed a real baobab tree under it. A forest. A monster.
Yeah, a real monster.
Or in front. Look, wow, beautiful, huh? It comes out whole. How nice. My suggestion, even to make it look better on video, is that we start assembling from the bottom up, from the tip that goes down there upwards. Is that okay?
Perfect.
Let's go. This is an adjustment sleeve because the 3 print was a bit bigger than the bar. So this plastic sleeve makes it fit tightly. I think we'll need some glue here, right?
For sure. We put some glue here, slide the sleeve down, and then put this on.
The plan is to use 72 screws. Actually 76. Aren't you going to give a lower number or something? Like, no. We thought it would be hard, but it's going to be easy. No, it just keeps getting worse. It just keeps getting worse.
I only realized later how many screws I was going to need. And then
with epoxy. Let's fasten everything with epoxy. Everything we can fasten with epoxy, we'll fasten with epoxy. It worked, right?
Yeah, it seems fair to me.
We have a start here. This is a tree support, but there's a bush here. It's a shame to screw in here.
And then the 4 of us grab and
This here is already really heavy. Pick it up and see for yourself. You see that? It looks like it's something light. This has got to be at least 2 kilos, right? Wow.
Just think there's gonna be another one of these.
Yeah. 4 more on top. I think this top is going to spin just fine as is. We won't need to fill it with plaster or anything like that. Filling it adds weight, which is good, but it'll be fine. Listen, why are there so many screws?
To secure it better? For what? Screws?
It's the Paraguayan joke, you know. I know. Well, let's tell this joke then. The person was there in Foz do Iguaçu, right? Where does this joke work in Foz do Iguaçu? A guy shows up with a gun and says, I'm Paraguayan.
I came here to kill. Kill who? A Paraguayan.
Paraguay. Picture this thing spinning with momentum. Give it a little spin so you can see. Do you think it's better for us to cut it? Do you want to put this here? Then we measure it closed, then we put the lid on, then we cut it. Shall we? Interns always get the honor, right?
Yay.
I can't give you a grinder, so it has to be with the hacksaw.
Okay.
Good luck to everyone.
How many days do I?
You have 5 minutes.
I understand.
I'll get some water. Meanwhile, you can...
I understand.
Congratulations.
In less than 5 minutes, okay? It's not exactly straight, right?
But it works. But it works, it works. Let's glue the bottom one.
Let's glue the bottom one.
This green one had a printing issue. The power went out mid-print, so the top wasn't finished. We printed the top separately, and now need to glue them together. This print came out poorly, and we're considering if it's worth reprinting. At first, I didn't want it, but now, looking at how much trouble this is causing us, I realize that it's misaligned on the inside too. So it's not good. It's really bad. I think we can use this one.
I think it's possible it'll just take some sanding work here where the bar fits in.
You don't want to fill this thing with plaster already. What's the issue? If we make it hollow, maybe it won't have enough weight spin. The plan was to fill this with plaster to make it heavy, but it's already pretty heavy. How many kilos do you think it is? Should we weigh it? Look, take a guess. 7. 5.3. Do you want to add plaster, shall we? Let's do it. We want to fill it with plaster and not concrete because plaster sets very quickly. In an hour, it will be solid, so we don't have to worry. But I wanted to add a bit of white glue. So this plaster will stick better, so it will be a bit stronger, so it will really adhere to everything here. And we have to do this with the spinning top hanging. So the plaster will distribute perfectly inside. This needs to be perfectly vertical. Otherwise, when we spin the top, it will end up a bit unbalanced. There's a 50-kilo bag of plaster here, and when you mix it with water, it gets even heavier. But I don't think we'll need to use all of it. It'll be a bit less than that. While the plaster is curing, I'll work on the top part of the spinning top. Now I'm without Alyson's help. Let's go. I think we have a problem. This blue piece is kind of damaged, probably when it was printing. It lifted a bit off the print bed. And if you look here, it got misaligned with the other pieces. You can see that the blue isn't lined up with the pink. So look at this center here. It looks weird. It's putting pressure on something. I'm not sure if the center is actually centered. We made this center here so the top would align perfectly and not be wobbly. But there are other ways to align it. Here on the edge, for example, every piece has a hole, which I can make a bit bigger with the drill. And then, by using these holes, I could theoretically fit it perfectly on top of the part that's already done. That's in theory, right? The plaster is supposedly cured. It's still slightly damp, but the necessary chemical reaction is done. Now it's time to test the alignment. Wow. I don't think I'm going to glue one part to the other because it doesn't seem necessary. Look, there's a little cap that goes on top here, and it closes the spinning top. It lined up perfectly here. I wanted to weigh this. I guess this weighs about 25 or 30 kilos. How much, Jansen? 26, 25.9, 26. That's quite a top hoe. It's looking good, huh? If I were watching this video, I'd already be giving it a like down below because come on, where have you ever seen a top this big, weighing 26 kilos? We were going to try to spin this here, but now everyone ran away. We're thinking that when the top falls, it's going to break because there's nothing inside. So if you hit a hollow part on the ground, the plastic probably won't hold up. When you hold it in your hand, you can almost hear the plastic cracking. Let's put expanding foam inside. Moisten it before using expanding foam. That's all we could do down here for now. Let's connect the top part and keep adding foam. My fear is that this will end up unbalanced. The foam isn't uniform, so there might be some gaps on one side and it's a bit denser on the other. It could cause a problem with the spinning top later. But anyway, I think it's better than it hitting and falling. I mean, better than it hitting and breaking. The foam will also work as glue at the same time. Allah? Let's seal it from the outside now, otherwise the foam will leak out when I put it in. I'm going to add more expanding foam. I still wanted to reinforce it with epoxy glue at the point where the spinning top touches the ground. It's just a line around it that touches, okay? It was already designed for that. Now it's heavier. I estimate that we put about 5 kilograms of expanding foam in here. Let's go. I'm gonna make a kind of band here using epoxy glue. That's this super strong glue. It's basically like resin and epoxy, but it cures much faster. In 10 minutes, we can touch it. I think that's enough strength for this 3D printed shell we made. Now there's not much else we can do. There's plaster, expanding foam, and epoxy. All three need to cure. Chemical reactions need to happen, so these materials reach their maximum strength. This top will have to rest for a while. It's time to test the little guy. Are you taking it over there by yourself like that? Can you handle it? No. This new generation. I'm not sure the drill can handle it. Are you really gonna stay underneath? Yeah, you'll have to give it a push, right? No, I don't think this needs a push. No, you can let go. Hey, man, this drill here has already been used as a boat motor. We're going to show the images here. It has also been used as a motor for a wooden cart and as a bicycle motor. Now it's a motor for a spinning top. Hey, stop. Before spinning this top, let's understand the logic behind why the top stands upright for so long. When the object spins, it gains a kind of magical stability. The name of this effect in physics is the gyroscopic effect. What happens? When the object is spinning, it's very hard for us to change the position of its axis. And that's why this top stays still here in my hand, as if it were magic, a balance that we would never achieve with the object standing still. But as the top starts losing speed, it begins to make this wobbly movement like this, kind of oscillating. The name for this is precession. And you will definitely see this happening with our giant top. It's really surprising. The top can precess almost horizontally. It keeps going down. But it doesn't fall. It takes a long time for it to fall. Now it does. Shall we try with something a little bigger? Before putting this top at risk of breaking, let's see how much it weighs. Man, I can't see here. 28.5 kilos. Held. That's a serious top, huh? Look. Wow. The noise wasn't very pleasant, was it? But you have to get more momentum. I have to admit, I was afraid it would spin too much. Let's try one more time. Oh my God. I'm so scared of this monster. Man, it's so beautiful. It doesn't fall. But when it does, I'm convinced I know what's gonna happen. Oh no. Let's get up so we can run if it falls. No. Look, if this isn't worth a like, I don't know what is. It's really cool. How much was it, Bia? Is that all? Now it's going, huh? Now it's going. It's crazy, but it's not totally balanced. Do you notice? Look how it vibrates on top. But even so, it's really cool. Look, it's been going for over 40 seconds now. I'm not kidding. It's lasting much longer and making a hole in the ground, about to spin inside it. It's creating a breeze. No, but something is spraying. It's water. It's water from the plaster or water from the foam. It's pushing the water out. Man, this is just beautiful. It's really beautiful. And it doesn't, what I think is most beautiful is this moment. Look, it doesn't fall. It dances. Shall we get up? How cute. Long. Bia, 1 minute and 52 seconds. No, it can go longer. It can go longer. It's fine. Now it's going. Now it's going. Only 1 minute and 8 seconds. The chuck wasn't tightened properly, right?
Throwing the termite?
But I feel sorry for the drill. It doesn't have much power at the start. That's all. Oops. A piece of it flew off. Is that it? Wow, now I'm afraid it's going to break apart completely. Get away from it. It's a crazy spinning top. Man. Wow. He lost a piece of the shell here. Look, I think, from hitting so much, it strained the 3D print. And even so, it's running really well. I have to admit, he kind of scared me. Look back there. It pierced the floor. Wow! This thing is really powerful. The centrifugal force was so strong when it was spinning at maximum speed that the top disintegrated. We talked a lot about what we could do to fix this top. We came to the conclusion that it was better to print the broken piece again and apply a generous layer of epoxy glue on top. We even thought about making it with fiberglass, but it would get a bit complicated and maybe pretty lumpy like that. So we'll go with epoxy, which I think looks nicer in the end. I have to admit that we underestimated the danger of this spinning top. Last time we were close to it, letting it spin, everyone happy. But the truth is, it can throw off pieces at high speed. So today, we're going to be much more careful with this thing. Besides, using a wire shield. I'm also going to use this shield here. It's so I can let the spinning top go. And if something breaks, it'll hit the wood and not fly at me. I don't think anything can fly off except plastic pieces. The plaster only goes up to here. Above that, it's just foam. If foam comes off, it's not a big deal. So the real risk is a piece of this PLA around it flying off. It's light, but at high speed. I think it could do some damage to our legs. He is reminding us to show the resin results, since he did it with a listen. He wants to display his work, which turned out like this. The pieces didn't stick together properly, right, Danny? All the resin ran down. There was little resin on top and a lot on the bottom. But I'm just kidding. I think it turned out well. It must have reinforced the 3D print a lot, even though the resin got in here between one piece and another. Deep inside, it must be making a big difference. Danny even put some varnish on top here because it was a little sticky. I think for us to test the spinning top, it's more than good enough. There's one more detail I was forgetting. It's this right here. We noticed that the spinning top was making a hole here in the stone near the pool. So maybe the best way to center the spinning top and keep it from making a hole or spinning aimlessly to put a bearing underneath. Now it will spin on top of the bearing. I think it will last longer and be more stable. Well, in theory, right? You're the one studying engineering at the University of Sao Paulo. I'm just making you responsible, so you don't say anything silly, okay? This bearing is meant to withstand weight in this direction, and we're going to put the weight in this direction, 90 degrees from what it should be. Do you think it will hold up?
It holds up because apparently it's a bearing that can handle weight in both directions, right?
It's balls. It's made of balls.
It handles radial and axial loads.
Radial and axial. Let's see if that's really true, huh? Put on your face shield too, man.
I'll stay up there.
Look. Yeah, I'll stay far away. Grab this dirt here, one here, because I'll need visibility through the middle here.
I'll time it over there on the other side, okay? Just for safety, but I trust you.
Yeah, I know. And are you two wearing glasses? Yeah. Stay behind the glass there. Stay behind the glass. Lucas, get inside, man. Let's all protect ourselves here. By the way, is there any left? And Jansen? No. Jansen is filming here, but he'll go over there later. Can I go? Let me see if this shield here worked. It worked. Look at that. Now I feel safe here, but the drill struggles to get started, you know. Oh my goodness. It's starting to scare me at this point in the game. Man, this is so beautiful. didn't time it just now, but it's spinning beautifully.
Yes, we are timing it.
Are you timing it? It's wobbling a bit on the floor. Huh. Wow! Come on, let's be honest. This is really beautiful. It's really beautiful. Let's try to fix it better on the floor and spin it one more time. I also didn't have the courage to spin it all the way. I was gonna do a test here. It didn't go to the maximum speed of the drill, no. Let's try to glue it to the floor with super glue, applying a QFS here first to get quick adhesion. So, what's your opinion about this ultra mega makeshift contraption?
Look, I think there's a better chance it'll work. You know, I think it'll spin for longer. At least it'll stay in the same spot.
Will this super glue really hold? Can it handle it?
Look, it'll be better than if we didn't have it, but it won't last until the end.
I think so. I don't think it will either. Still, it's worth trying since we have no other options. It's gonna rain soon. I'm already feeling a few drops, but let's try to do it before it rains. Ah, it held up.
Well, I'm going back there.
To my safe spot. Go back to your bunker, okay? Wow, if it reaches that speed, huh? Now it's getting violent. Man, he's kind of imbalanced. That's why he's like that. So, my God. LD. Now it's getting scary.
No!
Nobody expected that one. Huh. That he slipped off the bearing.
It got more balanced.
Man, his balance outside the bearing improved a lot. Look at this. It's really beautiful. Every second of this build was worth it. Huh, let's run it without, right? Because the floor is already damaged anyway. What bothers me is that it keeps slipping out of frame over there. But it got a lot more stable, because then the tip could...
The tip keeps adjusting itself, right?
It compensates for the imbalance. I think we're gonna run without it. Let's run without it. And the bearing didn't break. Point for you, huh? Jansen is saying that I'm not letting it go at full speed. Let's go. Whoa.
Oh!
Whoa!
Whoa. Thank God for that little shield.
Yeah. I think it's gonna take a while to pick up the pieces here.
Look. This time, I tried a speed I hadn't tried before. I was always careful not to spin it that hard. But the problem is, we start getting confident, you know, and then confidence is always the danger. So now, all that's left is this little spinning top here.
It'll stay in my memory.
It'll stay in our memory, and we have to hope that the slow motion Jansen setup worked well, because I think it must have turned out really cool, but thanks. And we learned that next time we have to wear safety goggles from the start. And not stay close to things that spin really fast.
And explode.
And that explode in the end. The plaster is still wet. That's why it burst. Yeah, because the plaster is wet. That's it.
Wait, look at this.
Yeah, no. To make a spinning top like this, guys, it has to be extremely solid in a way that I'm not sure you can guarantee it won't burst. Even if it were made of solid epoxy, I don't know if I'd have the courage to spin it at maximum speed.
Maybe with the parts we printed, if we made some kind of anchors to push the plastic more toward the center to hold it in place.
That could work, but it's just too fast in the end. I think a spinning top this size, that's why spinning tops this big don't exist, right?
We just found out.